Good afternoon, everyone. I think in Russian you call it Dobry день. So today I will be speaking in English. This is my first time in Russia and Moscow. So thank you for this big event in Moscow. I was really surprised when I came here to see such a big event in Russia, especially in cybersecurity. And today I actually wear Indonesian design, like this, so that you can know this is the Indonesian shirt, so that later when you come to Indonesia, you know that this is a special shirt made in Indonesia. Okay, so today I'm going to talk about the development of Honeynet threat sharing platform, and we have been doing this for the last 4 years. So I will be sharing my experience how we developed this for the cybersecurity community. Next. Oh, okay, sorry. Can we use this? Okay, yeah. I'm actually a lecturer in Swiss German University in Indonesia, and I'm the deputy head of master program. We have a cybersecurity program since 2008 in Indonesia, and I'm also the head of cybersecurity operations center in SGU. Also, we have a cybersecurity lab that we do several simulation and also a lot of malware analysis in our lab. I'm also a cybersecurity consultant. I have quite some certification from Easy Council and CompTIA, and I do a lot of training to government, private institution, and also professionals. So my agenda today is basically, I will talk about what actually initiate my research, which I received several research grants that I will talk about. And also, I will talk about the evolution of the architecture that we are doing to develop for cybersecurity community. And also, I will talk about the public dashboard, of course, their evolution from the beginning until today. And I will talk about later the insight that we have in our dashboard that usually people can extract them and use them for data analysis. And then finally, we will talk about the lesson learned from this threat sharing platform. So let me start with this one slide to discuss the research grant that we have received from the UPNIC Foundation. UPNIC Foundation is Asia Pacific NIC, the non-profit organization. They actually manage IP address in Asia Pacific, and we proposed this research in 2019, and of course we collaborate with several community. One of them is actually Indonesia Honeynet project, and the other is our National Cybersecurity Agency, which is BSSN. And today, BSSN, they send 2 people to come to Russia to learn about cybersecurity. So we are glad that they are here to learn about how we can collaborate between Indonesia and Russia. Okay? And so we are so looking forward to collaborate between Russia and Indonesia. So that is the first grant that we get in 2019. And the second grant we get in 2020. The goal is actually to deploy honeypots across Indonesia and to actually get the threat data and share them to the public. Because many of the community in Indonesia doesn't understand what cyber attack is. So we use these honeypots to actually get them to understand what does cyber attack look like. So we developed dashboard to give them ideas and visualization to picture that, okay, this is the cyber attack and this is how it works in Indonesia. And in 2021, we actually provide more data portability. We actually let the cybersecurity community access the data in TAXI and MISP form. By the way, TAXI and MISP is an open source standard, so people can use them for their research or for their incident response. Okay, in 2023, we proposed a new concept. Previously, we deploy honeypots in organizations such as academics, government, and private institutions. But this time, we propose to deploy in internet exchange in Indonesia. And not only internet exchange, we also propose that we want the honeypots to be deployed IP version 4 and IP version 6. So this is for the first time we actually deploy it in IP version 6, but in internet exchange in Indonesia. And so this is never done before. Okay? Now, this is our first architecture. We actually started to design the architecture starting from the left-hand side, in which we have honeypots that we deploy in organizations such as academics, government, and also private institutions. Now, we deploy this only using 2 honeypots at the first time, and then we use the open source HPFit to transport the data actually in the honeypots into the repository. We use what we call HPFits, and this allows us to transport the data into the repository. During the data transformation, that we use what we call honeypot data parser engine. We parse the data so that we can actually process them and put them into what we call visualization platform. Now, by doing that, we can actually get also the data and put them into visualization platform such as ELK, which is also an open source platform. Once we have done our job into analysis of malware, which we use Chuko Sandbox, we also put them into MISP, which is what we call malware information sharing platform, which is also an open source. And we can share them to the security researcher and also other people who are interested in our threat data. Now, this is our first public dashboard, very simple. Statistics, information, threat map, and also some information regarding malware that has been attacking our honeypots. Now, once we have the first architecture, we try to revise our architecture, and most of the revision actually centered around what we call the repository database. We use AngroDB, so that we can actually, ArangoDB, I think there is a misspell over there. ArangoDB, so that we can actually collect the data and process them and share them later to our community. And not only that, we can actually visualize the data using the platform. Okay? That's another advantage of using ArangoDB. Now, in the first revision of the architecture, we actually do several things that is quite a challenge. Number one, in doing any data transformation, we usually need to normalize the data. So data normalization means that we have to actually make sure all the data field, they are actually all in the same character, the same categorization. So in that way, we can actually display them and visualize them later. The other thing is we need to also think about data transport, because we figure that HP fits, it's not very good to transport all the data. So we need to design and think about what is the best data transport to transport our data honeypots into the repository. And the other thing that we also do is what we call the parsing engine. This, in the beginning, we use the regular expression methods. As you can see, most of them are usually strings related and symbol related. And the other, finally, is to actually configure the database so that they can actually have a quicker or faster query and update of database. Because in the beginning, we don't know much about how to design database so that it can have a very fast query and also update of database. So we learn through this, and we actually successfully configure the database to have a very fast query and updates. Now, on the second architecture, this is the second level, we actually added more honeypots. You can see on the left-hand side, we actually added several honeypots based on several other services other than common like SSH and other such as Telnet and many other data services. The other update of database that we also do is we now use the MongoDB clustering, meaning that we set up a clustering of MongoDB, meaning that all this clustering effect will actually help us to solve the problem of when we have let's say one database down, we can actually have the other database up and running, supporting the query. One more thing that we improve in the second architecture is the threat categories. And I will explain this in the next slide. The other thing is now we use the open source Grafana-based dashboards, which provide us with a better visualization and actually help us also so that people can actually understand what we display in the dashboard. Okay? So in the sharing of database, we also actually configure our taxi server. Taxi server is actually a server to transform data so that they are readily available to help people who wants to actually extract data and use it for their research. Yeah, they can actually use a query just like much of API today. Yeah, taxi server allow us to do that. Now, this is a much improved dashboard. We provide more honeypots. We actually now provide the source of the attack, and we also provide the mapping to what we call MITRE attack. Yeah, MITRE attack is actually the common language that we use today to map all those attacks into the tactic, the procedures that they use today. Now, these are the example how we actually do our threat categories. So for example, if we have a SSH command sent to our SSH server, we usually map this command into categories of threats. So for example, this proc CPU info, basically they are doing CPU profiling of our hardware. And we categorize, their purpose is to get the hardware info of our honeypots. And the other thing is, they may also run some execution. For example, on the second to the last command, they run a cron tab. That means they usually execute some command and they want to do some scheduling of tasks. Okay? So these are the threat that we use, that we call it a threat category mapping. And on the right-hand side, we actually use the MITRE attack. The MITRE attack actually is now online. People can actually take a look at what is MITRE attack. And basically, we can map those threats into specific technique. So for example, in the CPU case, we get the technique is called gathering victim host information. And we provide the title as discovery. Okay? So these are the threat category that we use so that we can understand what are the threat categories and what are the threat mapping that usually people use in exchanging information. Now, we also try to map the attacker behavior through the honeypots. One of the flow of attacker behavior looks something like this. So usually they start with the profiling, and once they do a profiling, they also try to modify. Maybe they will modify the command, maybe they will modify the permission, and they will start to download something into the host. And then after that, they will try to execute what they download, and using this command, they will enumerate maybe the user, maybe other networks, so that they can try to go to the next level. And also they try to be persistent, meaning that they try to exist in the host. For example, they will execute a cron tab so that they can continue to be actually exist in that particular host. And the other thing is they also try to wipe out their existence. Yeah? They try to wipe out the log so that people don't know that they already visit the host. That is one of the what we call the covering tracks. And later, we also measure the impact. So what sort of the impact they do on the host. And sometimes this particular malware or this particular attack, they actually try to jump into several hosts, try to infect other hosts so that they can do more damage into other network hosts as well. Now, on the third level architecture, this is when we also add more honeypots, right? On the left-hand side, I think you can see the list of honeypot that we implement. And we also, for the first time, we pre-process the data at the source, right? We used to process the data after they put it into repository. Now we pre-process at the honeypots. This will actually make our pre-processing much faster, and we can also process the data later in a faster way. Now we also develop a custom data transport so that we can transport the data according to each of the honeypots so that they can actually arrive with the right data normalization and we can process them further. Now, we also map into a much more advanced threat. And of course, we also created, this is still in planning, and hopefully by toward the mid of the year, we can actually have a data set ready for people to download. Maybe they can do a 1 month data set or 3 months data set. This is important. Usually people who are doing machine learning or even AI today. Now, on the right-hand side, you can see we also created a new cybersecurity community, which is called CSC ISAC. Yeah, CSC ISAC stands for Cybersecurity Community Information Sharing Analysis Center. The goal is that we want to use this community to share our threats to the community, of course, to the Asia Pacific, and of course, to the world. Now, in 2022, I and the other colleague from New Zealand, we get an award from our project, and this is actually awarded in 2022. So we are very glad that our project is well received by the community, and that's why we come here to Russia for the first time to present what we have done in the Asia Pacific, and hopefully I'm actually talking to some of the university in Moscow so that we can actually work together to do more threat research. Now, this is more on the intelligent side. in which on the center over there, we enrich the data in which that this data now can have more information. We added like IP address mapping into autonomous system numbering, okay? And you can see that later. So this is our dashboard for our tenants, okay? Sorry. Yeah, I hope this is now clearer. Yeah, so if you take a look at this dashboard, this is dashboard for our tenant, meaning that our customer or people who actually, or organization who install our honeypots, they can come to this dashboard and they can download their own data. Yeah, because this data can be used later for their own research, for their own purpose. Now, this is an example on how we map into the IP address into the autonomous numbering. Okay? We found out that 30% of the attacking IP address actually come from research organization. Okay? This is also quite surprising to us, even though we know that some organization actually do some worldwide scanning. So we found out that this actually help us to understand why there are so many attacks from some IP address, but we find out later they are actually a research organization. Now, the other thing that we also find out is Telkom Indonesia is the largest internet service provider, and they are the largest IP address that attack our honeypots. That means this is for the first time, it's not United States, it's not Russia, it's not China, but it's Indonesia that attack Indonesia. So this is quite interesting. That means it's growing cyber attack in Indonesia is now happening, okay? So this is quite interesting. And we have some friends actually told us from China, yeah? The mobile malware is also increasing in Indonesia. And so this is also another reason why we need to collaborate with many nations so that we can actually understand the threats much better. The next IP address that we receive is actually from Vietnam, China, and Korea, which is actually in the Asia Pacific region as well, okay? But this is just to give you idea, this is what we are now actually understand in our honeypots. Give us more insights into what we are doing. Okay, this is just to give you some statistics from different company, different ISP, because they usually provide us how many IP address coming from this company. Now, the next generation architecture that we are developing is basically based on the architecture that we put into Internet Exchange of Indonesia, or we call it IIX. So what we are doing in this architecture is we put the honeypots in the Internet Exchange because we never actually understand what is the attack and how many attack actually in IP4 and IP6. So this is the first time we try to understand cyber attack in IP version 6. Okay, so this is something very interesting to us, and we are now trying to enrich the data so that we can share it to the public. Now, this is the how we actually transport it in from different region into our central database. And these are the monitoring dashboard, and people can come into this dashboard and try to look at the statistics of attack in the Internet Exchange. And so this is published by the Association of Internet Service Provider in Indonesia. Okay, so we now understand what are the attack actually happening in our Internet Exchange that we never understand before. So this is quite interesting, and that's why we want to announce this to the world, and also it's useful to the member of the association. Okay, now, of course, we are now trying to expand this to the Southeast Asia country, and of course later to Asia Pacific. Today, we also announced this to our partner. I'm invited by the Positive Technology. So this is becoming our new partner, and we hope that we can also collaborate with Russia to find out how we can work together to work on the information sharing, not only in Asia Pacific, but also in the world. So this is our publication. Basically, this is what we have publicized both in the IEEE conference journals, so that people can understand what we have doing. And the website is there. You can actually take a look. And of course, you can also download if you need to collaborate with us. We are welcome for the collaboration. So the question is what we have learned from this project. Number one, we have actually understand that it is always best that we pre-process the data in the honeypot, which is actually at the source. Now, this helps us, of course, to provide us faster delivery of data, and of course, faster of normalization of data. The second thing is, of course, we are now developing a better and robust script processing. We used to use HPFit, we used to use Logstash, and we also use Python script. But now, we are experimenting with an open source of FluentD, and hopefully this provides us with more robust method of transporting data. Now, we also now find out that our clustering actually provide better and also speedier data repository. So allow us to pre-process and also process our data much faster. And also we have a student, a master student who just graduated. He's talking on the, I think on the other hall. He's actually using this data for AI. So I think he's talking using like natural language processing and other AI methods to process the data for more threat analysis. And last but not least, we actually already provide taxi, MISP, and future we want to provide data sets so that people can actually use them for their research and collaboration. And I hope this can help us to understand better what are the attacks and how big is the attack and what is the nature of the attack, the behavior of the attack, and finally allow us to collaborate more worldwide, not only in Asia Pacific, but also today in the world. I think that's all from me. Thank you very much. Spasiba. Should we take some questions? Is it from here? Okay. Okay. Okay, so there is a question from Puma. Have you ever met attack on honeypots aimed to poison gathered data with fake actor behavior or deliberately lead security researcher wrong way and make wrong conclusion? Yes, thank you for the question. I think yes. I think they usually when they actually attack honeypot, I would say 80–90% of them, and most of them are actually botnets, and they actually use, of course, using different IP address and also different country, and they jumping from country to country. And of course, they usually try to use this to actually hide their presence so that people don't know who they are and what they are actually doing. Of course, they have sent some comments. We know what they're doing, but We don't know who are they, except that they are actually coming from different country. But the new revelation coming from, mapping IP address to autonomous number help us to actually drill down whether this is organization attack or is it actually an individual which leads to the threat actor. Okay, so let's go to the next question. This is also from Puma. Using limited service in honeypot give limited value because client may want to have result based on infrastructure similar to theirs. How do you solve this problem of this limitation? Oh yeah, very good question, Puma. Actually, I haven't announced this. Behind the scene, I have a student who actually now doing what we call dynamic honeypots. And we are using AI to generate dynamic response so that they will not know whether this is honeypots or this is actually the real surface. And they will look like a real surface because the AI, today we already know that a large language model provide a very realistic response to the query that we actually give them, right? So what we do is at the back end, we provide some AI response to the query that they gave us in the honeypot. And so we give them the response from the AI that we actually generated at the back end. So this is what we are doing, and the hope is that we can actually increase the deceptiveness of the honeypots. Because right now, people will actually come to a honeypots and they will know, oh, this is honeypots, so will not attack. Okay, so sometimes they are doing that. Okay, so with this new generation of honeypots, we will be able to actually generate real response to the real query of the attack. Okay, I think this is another question from R. How can I get the access to the public APNIC Honeynet dashboard display of the attack? Can you provide the URL? APNIC website is some complicated, find this information. Oh yes, very easy. You can go to the public.cscisaac.org. Okay, so public.cscisaac.org. Next, this is a person from Keanu. Okay, hello, thank you. Can you tell more about Windows-based honeypot and where can I buy such a nice Indonesia shirt? Okay, sure. This is a two question. One is more for Windows honeypot and the other for Indonesian shirt. So for Windows-based, of course, most of these simulations are actually Linux-based. But of course, now we have research that is now doing using AI-based. In the response, later we actually will produce not only Linux, but also Windows-based response. So hopefully in the next 1 or 2 years, we can actually produce open source Linux and Windows-based honeypots. Yeah, regarding the shirt, actually there are many websites that sell shirts like this, okay? And you can go to, they call it Batik Kris, but if you need to, the link, I will provide the link to the person who is responsible here, and you can get it from them, okay? It's a very simple website. You can actually order from them, and they can send it to you. Okay, I think this is the last question. Okay, I think this is from G413K5. Hi, which tools of technology do you use for administration different type of honeypot, of different custom honeypots? Thanks. Okay, right now we are actually using a very simple SHH tools to manage all our honeypots. Of course, in the future, we are trying to build a very simple dashboard monitoring for our honeypots. We already built a monitoring dashboard, but we haven't built yet the administration side of the honeypots. So maybe we will do it next year when we can actually manage the honeypot automatically.